let's calculate the derivative of this function on the screen there. The first thing you got to notice about it is that you have two functions nested, composed, right? This is the composition of tangent with 12x times e to the x. So it's two functions. When you plug in an x value into this, first you plug it into this, 12x e to the x. Whatever is the output of this, you take the tangent of that output. So it's two functions. We're going to have to use the chain rule. So what does the chain rule say, and how do we make it work? I'll call this thing u. So that means y equals the tangent of u. And u is 12x e to the x. So I'm actually going to write y equal to, since I know tangent is sine over cosine, I'm going to write it like that. Sine of u times the cosine of u. And that's because if I had memorized that the derivative of tangent equals secant squared, I could do that. That's fine. But I don't want to bother with that. I don't want to have to memorize all of those things. I'm happy with just remembering that the derivative of sine is cosine and the derivative of cosine is minus sine. So I'm going to do it that way. So here's the chain rule. How do I derive dy dx? Well, by the chain rule, that's dy du times du dx. Remember, right, that those two appear crossed out like that, so that I can, if I cross them out, I get dy dx. So that helps you understand why the formula for the chain rule works that way. And now what's left for me is to find those two values and then multiply them. So let's try the first one. What's dy du? So that's d du of y, which is sine u cosine u. So that's the derivative of a quotient. So the derivative of this quotient is the derivative of the first. I use prime notation now. Times the second minus the first, the derivative of the second. And here I'm pretending u is my variable, u is my independent variable, playing the role of x, divided by the second squared. Derivative of the top times the bottom, top times the derivative of the bottom, over bottom squared. So I gotta fix that. And that's gonna give me the derivative of sine equals cosine minus sine. The derivative of cosine is minus sine, and all that over cosine u squared, or cosine squared u, the same thing. So that's then going to be cosine squared of u plus, because of the two minuses, sine squared of u over cosine squared of u. So how cool is that? That this is the Pythagorean identity, cosine squared plus sine squared equals 1. So this is 1 over cosine squared of u. So that's 1 over cosine of u squared. So that's the secant squared. So if you already remember that, you can just skip all of this process and you'll be happy with this. You'll be done. If you remember that the derivative of tangent is secant squared, I'm okay with that. But if that were cotangent, right, then you'd have to remember that one too. So I just think it's worth using the quotient rule. It's just a few minutes. Now let me go purple to do the other thing that I need to find, which is du dx. So du dx is the derivative of this. And for that I use the product rule instead. So the product rule, first the constant multiple rule allows me to change and bring this 12 out. And now the product rule is the derivative of the first times the second plus the first times the derivative of the second. So that is 12. The derivative of x is 1 times e to the x, that's just e to the x. And the derivative of e to the x is just e to the x. So that's what I have. I can even distribute these over. So I have that, and I have that. So now if I go back to blue, dy dx is secant squared of u times 12 e to the x plus 12x e to the x. So it's customary to write those before the trig function so that there's no confusion and someone doesn't think that you're calculating the secant of all this. So I'm going to write all of this in front. And that will then be 12 e to the x plus 12x e to the x times the secant squared. And instead of writing u now, I'm going to go back to the x variable, because remember, u was this, right? 12x e to the x. And then I can use distributive property to find my final answer as being 12 e to the x secant squared 12x e to the x plus 12x e to the x secant squared 12x e to the x. Some people will like this. That's okay. This is a nice looking answer, I think. Two different things adding. I'm okay with that. But some, I'll use maybe black on that. Instead of following this path here and expanding, we'll try and factor more things out. So from this step, instead of foiling, they'll factor e to the x out to get, and maybe the 12 as well, right? Because the 12 also shows up. So they can factor out a 12 e to the x to get something like 12 e to the x times 1, because that's what you get from here, and then an x, which is the only other thing left from here, and then times the secant squared of 12x e to the x. I'm happy with either answer, but make sure that you're able to produce both, just in case anyone requires you to use this other format.